In this section, we're going to introduce applications. And with applications, we have to understand the difference between an expression and an equation. An expression is a meaningful collection of numbers, variables, and operating symbols. But the most important part, I think, is the fact that there's no equal sign. You're just describing how something is related to something else. But if you have a mathematical sequence stating that two expressions are equal to each other, now you have an equation, and that is where the equal sign comes into play. And only when you have the equal sign are you able to solve for a variable. If you have an expression, you may be evaluating an expression like we did before, but you are not solving if you have just an expression. So then the next part is we're going to be translating words into symbols. So I need you to stop the video and kind of go over this slowly, take some notes if you'd like. First, addition can be implied or stated using these words: plus, sum, more than, added to, or increased by. Order doesn't matter. Let's see, for subtraction, you'll hear words like minus, subtracted from, less than, difference, and decreased by. Order does matter with subtraction. Multiplication, you'll hear words like multiplied, times, of, product, twice, triple, quadruple, whatever. Order does not matter. For division, words like divided, ratio, or quotient. Typically it's quotient. Equals, you'll hear things like equals, is the same as, result in, and so forth. Now, we're going to work first of all with some expressions. Remember from above, this is not an equation. It doesn't have an equal sign. They're just describing a relationship. So let's go ahead and look at our first one. The quotient of a number and 12. First of all, when you see the word quotient, you know that it's a division. Excuse me. And the description is the quotient of a number and 12. Anything you don't know will automatically be used or designated as X, as you saw in the directions. So a quotient of a number and 12. A number that will go on the top, and then the 12 will go on the bottom. If you have an expression described to you as a number increased by 11, okay, a number to be increased by means you're going to add something to it, and that would be our 11. A number increased by 11. 3/4 of a number. Okay, I'm going to write down the 3/4 of implies multiplication. So I'm going to put that in parentheses in case there's more than one piece. 3/4 of a number. I don't know what that is, so that's our X. And then finally 13 decreased by. So I'm subtracting something from 13, a number. 13 is going to be decreased by, which means I'm subtracting something from it, and that would be our number. And again, don't overthink those. They are actually pretty straightforward and logical. Just know the phrases and the words that can represent those things. And again, you can stop the video and go back and look at those at any point. Decide whether each of the following translates into an expression or an equation, and then write the corresponding expression or equation. Remember, an expression is just a way to describe something. An equation will actually have an equal sign in it. So it'll have the word equals, is, the same as, results in, words like that. And that implies the equal sign, and that would make it an equation. Let's look at the first one. 9 is, there's an equal sign. 9 will be equal to 5 less than a number. Okay, 5 less than a number. When I have a number and I want to find 5 less than it, or let me give you a better example. If I told you that I had $10 and you have 4 less than 10, you don't do 4 minus 10, do you? If it's 4 less than the number 10, you would actually do 10 minus 4. So same thing here. I don't know what it is about the words more than and less than. They're almost always written the opposite of how they're stated. So if you're going to do 5 less than something, you're going to subtract 5 from something. From what? A number. This is an example of an equation because it has the equal sign in it. Now let's look at number 6. 10 less than a number. Again, 10 less than something. Well, I'm going to subtract 10 from something. 10 less than what? A number. Remember, the words less than and more than, for some reason, they're almost always stated the opposite of how they're written, or written the opposite of how they're stated. And let's look at number 7. 4 times a number is the same as 6 more than twice the number. There's the word is. There's my equal sign. So this one is going to definitely be an equation. Oh, excuse me. The last one didn't have an equal sign in it, so it is an expression. Sorry about that. Number 7. 4 times a number. Well, how do you do 4 times a number? I multiply 4 times x, which is that number we don't know, is the same as. Okay, that's definitely our equal. And here's the second statement. 6 more than twice a number. Well, if it's going to be 6 more than something, it's going to be bigger by 6, isn't it? Twice a number is what it's 6 more than. Twice a number is 2x. And that is definitely an equation with that equal sign sitting there. All right, let's go on and do some notes first. Setting up and solving applications and word problems. First thing you want to do always, and I do agree with this completely, you want to read the problem completely first and look for any kind of things you can identify. Then you want to assign a variable to represent what we don't know. We've been calling that x so far. Then write an equation using the keywords from the problem and then solve. State the answer with correct units and make sure that your answer is reasonable. So if you're finding feet, or if you're doing a word problem where you're finding gallons of something, you do want to use those units. And then finally, always with any equation, you can check your answer. Let's keep going. We're going to solve each problem by setting up and solving an algebraic expression. Make sure you put the correct units on your final answer. And for instance, if we're finding feet or miles or gallons, okay? Now, if 3 times a number is subtracted from 8, the result is, there's my equal sign, the difference between twice a number and 7. Find the number. Okay, I found my equal sign, so I know it's going to break up right there. The first part says 3 times a number is subtracted from 8. Okay, 3 times a number is what's being subtracted from the 8. So the 8 has 3 times a number subtracted from it. And then read it back again. 3 times a number, there it is subtracted from. The 3x is going to be subtracted from 8. I believe we have that side correct. Let's look at the other side. The difference between, okay, that's describing a subtraction. The difference between twice a number and 7. And again, when they give it to you that way, you just want to write down twice a number and 7. That's what we're finding the difference in. And we get to solve. So we get to go back a couple of sections now and solve. Remember, we want to get all of our x's on one side, all of the constants on the other. I'm going to again continue to solve with my x's on the left, so I'll move the 8 over to the right hand side. When it crosses over the equal sign, he becomes a -8. The 2x I'd like on the left, so when that 2x comes over to the other side, he's going to become a -2x. Now clean it up. I'm going to combine the like terms on the left hand side. -3x and -2x add up to -5x. -7 and -8 add up to -15. Now, to get the x all by itself, I can divide both sides by -5. That's always our last step. And we get x is equal to 3. Since we were just finding a number, that's it on that one. Let's look at number 9. On number 9, it says John is 6 inches taller than twice his daughter's height. If John is 78 inches tall, how tall is his daughter? Okay, well, they're giving us John's height described in terms of his daughter. Like they're pretending we know how old his daughter is. And then eventually, even in the question, it says, how tall is his daughter? We're going to let her height be X. That's what we don't know, but they talk about it like we know it. So here's John's height. John is 6 inches taller than twice his daughter. If he's 6 inches taller than her, we're going to add 6 to her height. We don't know her height, but we're adding 6 inches more. He is 6 inches taller than twice his daughter's height. Twice her height is 2x. The other thing that they told us is that John is exactly 78 inches tall. Oh, that will equal to 78. See, they described John's height in terms of his daughter, and then they gave us his height. So we can set them equal to each other. Now we can solve for his daughter's height, which is that x. I'm going to start by moving the 6 over to the right-hand side to get the x's all by themselves. When it crosses over the equal sign, we get a -6. So now we have our 2x equals, and 78 minus 6 is 72. Feel free to pause the video anytime you need a little time to do the arithmetic. Finally, to get the x all by itself, we're going to divide off the 2, but if you do it to one side, you're going to do it to the other. So the answer will be 72 divided by 2, which is 36. And we know that this height is in inches, so our answer should also be in inches. And one more on this video. An Uber driver charges a base rate of $6 along with 25 cents per mile. A Lyft driver charges a base rate of $4.50 along with 40 cents per mile driven. What number of miles will the charges be the same? Let's just start down by writing what Uber charges and what Lyft charges right next to each other, because they're comparing something. The Uber driver charges you $6 when you get into the cab, and then they charge you 25 cents per mile. Since I don't know the number of miles we're looking for, or that, that happened on the trip, we're going to call that X. Now, the Lyft driver charges $4.50 as a base rate when you sit in the car, and they charge you 40 cents for every mile that they drive. Once you have the two expressions written down, they want to know, for what number of miles will the charges be the same? And there's the key word. Being the same means when will they be equal? And now we can solve. Oh, and by the way, I did something wrong here. Because the $6 and $4.50 are in decimal, 25 cents a mile should have been 0.25, and 40 cents a mile should be in 0.40. I apologize for that. Please change that. All right, let's finish. I want to get the x's all by themselves on the left, so I'm going to move the 6 over to the other side. It's going to become a -6. I'm going to move the 0.40x back over to the other side. That's going to be minus 0.40x. I'll go off into the margin and add those together. Let's see, 0.25x and minus 40x. That's going to be -0.15x. On the other side, 450 and minus 6. When I clean that up, I end up with a -1.50. All right, to get the x solved for, all I have to do is divide both sides by the -0.15 to get the x solved for. And I end up with x is equal to 10. And the units, we were looking for the number of miles that would make the two expressions equal. And there it is. I'll see you in the next video.